This is the second part of the review activity, where we are going through just basically these questions. I think more or less we can cancel these ones. They're not going to be on the test. I won't ask you. These questions we'll be focusing mostly on this stuff. We'll do some easy questions, hopefully that are like these 2 pages. So this is a dilution kind of question. What volume of H2SO4 should be created? So this is basically, again, you're essentially doing C1V1 equals C2V2. So C1V1 is the before dilution, so this is the C1. What volume? So we have to find V1. This is V2, it's 2.5, and this is C2, 0.75. So all we're going to do is going to say C1 is 18.0 times V1 equals 2.5 times 0.75. So if we do 2.5 times 0.75, we get, let me grab my calculator. This is 1.875, and then we have to divide both sides by 18 to cancel and isolate for V1. So if I divide 2.5 times 0.75 divided by 18, it gives me 0.104 liters, which is my answer. And again, our next question is very similar. So we have 300 milliliters, which is V1, 6.5 mole per liter, C1, diluted down to 1 liter. So this is V2. What is the new concentration? C1 V1 equals C2 V2. C1 is 6.5 times 300. You can leave that in milliliters, but convert it to liters is better. And again, this is 1 liter. This is V2 times C2 is what I have to find. So this 1 is just divide by 1, which doesn't really change the answer. So my C2 is just 6.5 times 0.3, which is 1.95 moles per liter is my new concentration. Okay, so I have 300 gram sample of iron ore, which is iron oxide, is converted into iron. How many moles of iron are produced? Okay, so first we have to find how many moles of iron oxide I use. So first, this is like a kind of the grams of iron is what I'm finding. So this is essentially a mass-to-mass question. So what I have to do is find, first I have to go from mass of Fe2O3 to moles. So first I have to do mass, which is 300 grams, divided by moles. So what is the molar mass of Fe2O3? It's apparently 159.69 grams per mole. So this gives me 300 divided by 159.69 is 1.8786 moles. Now we have here a ratio. 1 mole of Fe2O3 gives 2 moles of iron. So 1 mole Fe2O3, 2 moles of iron. No space. Arrow 2 moles of iron. So 1.8786 moles of Fe2O3. Again, from here to here, I'm going to multiply by 2. So this answer, I'm going to also multiply by 2 to give me 3.757 moles of iron. So that's the answer to the first part. How many moles of iron are produced? 3.757 moles. And now again, I have to go back from moles to mass. So I'm going to multiply by molar mass of iron, which if you look at a periodic table for iron, it's just 55.6484. think it's 55. I think that's it. 50.85. And again, I'm using the formula to calculate mass. I have to do number of moles times molar mass, right? So I do this times 55.85, and I get my mass is 209.84 grams is my mass of iron produced. Okay. So here, we basically have a reaction so we have to write a reaction, basically, which is the hard part. Aluminum plus oxygen gives us aluminum oxide. Thing is, we have to balance it as well, which is balanced like that. So now, how much oxygen is needed in moles and grams? So 5 grams of aluminum we're given. So again, this is a mass-to-mass question. First we go from mass of aluminum to moles of aluminum. So that's 5 grams of aluminum divided by molar mass of aluminum. Molar mass of aluminum is 26.98. So 5 divided by 26.98. So I do mass divided by molar mass equals 0.185 moles. Again, I did this by doing 5 divided by 26.98 over here. And then I do my little conversion. So 3 moles of aluminum needs 2 moles of oxygen. So here, to get from 3 to 2, I have to kind of multiply by 0.666 to get me from 3 to 2. So I'm also supposed to multiply this by 0.6, which gives me 0.123 moles of oxygen. Now to convert that to grams, I have my moles of oxygen. I'm going to do mass equals number of moles times molar mass. So I have to multiply this by 32 because oxygen is 32 grams per mole because O2, 16 times 2. If I multiply that by 32, I get 3.946 grams of oxygen. So that's how much oxygen is needed. What is the mass of aluminum oxide? This is almost exactly the same kind of question, right? I have 135 grams of aluminum here, and I have to find the mass of aluminum oxide. So again, we're going to do 135 grams of aluminum. We're going to divide by the molar mass of aluminum, which is 26.98, and that's going to give me 135 divided by 26.98. It's going to give me 5 moles of aluminum. 2 moles of aluminum gives me 1 mole of aluminum oxide. Right? So 5 moles of aluminum, so I'm going to divide by 2 or multiply by half realistically. Same thing, right? So I have to multiply this also by half, which gives me 2.5 moles of aluminum oxide. So I have to find the mass, which again I have to multiply by molar mass of aluminum oxide, which happens to be 101.96. I'm going to do divide by 2 times 101.96 is 255.088 grams of aluminum oxide is produced. So we'll do 10 down here. This is an example of a limiting reagent question. So again, 2 steps at 0.04, so CuCl2, and I have to do aluminum. So I have 0.04 moles of this and 0.05 moles of that. So I'm going to find my least moles. And I do that by doing 0.04 divided by 3, and 0.05 divided by 2, which in this case would be 0.013 and 0.025. So this is lower, so this is my limiting reagent. Now, as soon as I have that, and my copper chloride is my limiting reagent, how many moles of AlCl3 is produced? So I know that 3 moles of CuCl2 gives 2 moles AlCl3, and so 0.04 moles of CuCl2, I have to, again, do times 0.6. So I'm going to do 0.04 times 0.66, which is 0.026 moles AlCl3. So this is one of my answers, and I have to find how much excess reagent I have, right? So I do 3 CuCl2 reacts with 2 aluminum. So 0.04 CuCl2 is going to react with 0.026 aluminum. So my balance is going to be 0.05 minus 0.026. So what I had here minus 0.026, which is 0.023 moles aluminum excess. Right, so we're just going to open up a blank page so we can complete these questions. 0.9 moles of CuCl2 and 0.5 moles of aluminum. So again, we're going to write CuCl2, aluminum, 0.9, 0.5. Again, divide by 3, divide by 2 to calculate least moles. This time aluminum is lower, so aluminum is limiting reagent, right, with 0.5 moles. So again, how many moles of copper is produced? So here I know 2 aluminum gives me 3 copper. So 0.5 aluminum, this is multiplied by 1.5, so I multiply this also by 1.5. So you get 0.5 times 1.5 is 0.75 moles of copper. If I want to calculate my excess, 2 aluminum, 3 CuCl2, so again 0.5 aluminum would be 0.75 CuCl2. So my excess here would be 0.9 minus 0.75. Excess copper chloride. And that's how you calculate the excess copper chloride. So this is very similar to a mole-mole conversion that we did with our stoichiometry. So we took our least moles, then we set up our mole ratios. 0.5 moles of aluminum is what we were given, and we just did times 1.5 times 1.5. So this is moles of our product. To find excess reagent, we set up the same ratio, 2Al is 3 CuCl2. Again, those 2 and 3 and 2 and 3s are all coming from our balanced equation. 2, 3, 2, 3. Right? And then again, 0.5 aluminum is 0.75 CuCl2, but I had 0.9 moles of CuCl2. So the balance, if you do the subtraction, whatever is left over is my excess reagent. So I don't know how to. Yeah, I don't know what happened. I think we have one more question left to finish. But my review is gone. Oh, that's the wrong button. Blank page. Practice test. Was it this guy? I think so. I'll open with it opened up again. Okay, we're going to do question number 11. So find the mass percentage. So we're going to do mass percentage equals mass of solute divided by volume of solution, just because that's easier. So mass of solute is, let's see, (74.4). So first, to find the mass, we have to do number of moles times molar mass. Number of moles is 2.75. So this is 2.75 times molar mass is 74.44, which gives us 204.71 grams. So here I do is equal to 204.71 grams. Volume of solution is 3.75 liters. So 3750 milliliters. So divided by 3750, which equals that, and times 100%. So my mass percent is 5.45 or 46%. That's the mass percent that I get. And that concludes our practice test. Those are going to be the main types of questions that are on our test, so very similar types of questions. So I will see everybody in class. Good luck.